All right, the next type of problem we want to answer is, will anything precipitate? Now, you need to get good at understanding the vocabulary and writing the equilibrium reactions um, as we before you tackle this problem, because this one is long, this one is complicated. I'd like to point out that with our flow chart, where you decide if it's an acid, a base, or a salt, you decide between whether the salt is soluble or insoluble. And the will anything precipitate questions start with two salts that are soluble. The two salts mentioned in the problem are soluble, and here's how you know: because it's a solution, and a solution means that it's dissolved. So I have 100 milliliters of 2 times 10 to the minus 8. Um, sorry, I have 100 milliliters of 2 times 10 to the minus 8 molarity lead 2 nitrate. That is in solution, that is soluble. Additionally, if I looked up lead 2 nitrate in solubility tables, I would see that it's soluble. Additionally, I do not find it on my KSP table. But even if I did, it could be that this concentration was low enough that it would be soluble at that concentration. So the context of the question is that these two solutions are soluble. So will anything precipitate means, am I forming something that will not dissolve? Am I forming an insoluble solid? These are like our double replacement reactions, our precipitation reactions we did back in Gen Chem 1. You can go back and review those. But if there, again, there's a certain pattern. This is kind of lengthy. You have to figure out step by step. And your first homework set, your first practice set walks you through step by step. What do I have to do? And I'm going to walk you through it now. So these are soluble compounds. So with my lead 2 nitrate, I am forming lead plus 2 ions and nitrate ions. The stoichiometry is such that I'll form 2 of those nitrate ions when it dissolves. That's important. Keep that in mind. With my second solution, I'm forming sodium ions and bromide ions. And the question is, if those 4 ions are floating around in a container, are there 2 of them that want to get together and form an insoluble solid? Are there 2 of them that make up something that is insoluble? Here's where you're going to go look at your solubility tables. You're going to go to solubility rules, something you may recall. Anything with a sodium ion is going to be soluble. Doesn't matter what the anion is. If the sodium ion is the cation, it's soluble. So I know that my insoluble solid is not going to form from my sodium ion. Likewise, if you look up the tables, or not the tables, a solubility rules chart, you'll see that nitrate ions are always soluble. So the only precipitate possible here is lead 2 bromide. The lead plus 2 ion plus the Br minus. What does that formula look like? That looks like PbBr2. That is the possible precipitate. And you have to determine, will it precipitate? Now, lead 2 bromide is insoluble, but again, there's a gray area. If the concentrations are small enough, it will stay dissolved. It's only once you get above a certain concentration, usually they're pretty low. Once you get above its molar solubility, then it will start dissolving. All right, but there is a small amount that does dissolve. There's an equilibrium reaction, etc. So in order to calculate will anything precipitate, this is back like our equilibrium chapter, our module on equilibrium, when we first started looking at it. What's the value of Q? And based on that Q, which direction does it shift? Because this is, again, I have insoluble equilibrium reaction. PbBr2 solid is in equilibrium with Pb2 plus 2 Br minus. The question is, in this equilibrium reaction, which has a KSP associated with it, if I dump in a certain concentration of lead ions and bromide ions, number one, is it at equilibrium? And number two, if it's not at equilibrium, will this reaction shift to the left to form the solid, which would cause the precipitate? If the reaction shifts to the right, based on the amounts I dump in, the right are the ions, which means there would be no precipitate formed. If it shifts to the left, then a precipitate would form. If it shifts to the right, no precipitate would form. So this ties into what we already did in the equilibrium chapter, in the equilibrium module, looking at the value of Q, seeing which direction it shifts. Again, the process for doing that is a little bit convoluted. So we need to figure out what the equilibrium concentrations of the lead ion and the bromide ion are. This is solution stoichiometry. This comes straight out of Gen Chem 1. So let's jump in. I'm going to pull this down so that I can look at these values and do my calculations here. So, or actually, let's do it that way. All right, I'm going to pull these down. All right. So I'm trying to figure out the equilibrium concentration of Pb plus 2 ion and the Br minus ion. I need those for my Q calculation. M1V1 equals M2V2. I am taking 100 milliliters of 2 times 10 to the minus 8 molarity lead 2 nitrate, and I am diluting to 250 milliliters. We saw some similar types calculations in the last module. So M1V1 equals M2V2. The concentration of the Pb plus 2 ion, oops. You guys double check my calculations. I get 8 times 10 to the minus 9 molarity. I would want to keep extra sig figs. This is all my calculator's given me, so I'm not going to necessarily write the 0.000. If, just a note, if I were calculating the nitrate ion concentration, if I needed the nitrate ion concentration, I would have to multiply by 2 because 2 nitrate ions get produced when that dissolves in water. So 100 times 2 times 10 to the minus 8 divided by 250 times 2 for those two. If there's a 3 subscript on an ion that I need to calculate for, it's times 3. So you've got to watch your solution stoichiometry. All right, now let's do our Br minus ion concentration. Again, M1V1 equals M2V2. I'm just producing one of those bromide ions, so 150 times 1.5 times 10 to the minus 10 divided by 250. His concentration is 9 times 10 to the minus 11 molarity. So those are the equilibrium concentrations of the lead ion and the bromide ion. And now I will calculate Q to compare it to K. And let me go back up here and look at that equilibrium reaction. I am calculating Q for this reaction in orange, which has a K value. I haven't written it yet, but that's what I'll compare it to. Let me go ahead and grab that. 4.6 times 10 to the minus 6. That's the K value from the KSP table. So Q, which is the concentration of Pb2 plus ion, times the bromide ion squared. Everybody see where I got that? So now I will take those equilibrium values, these equilibrium values, and plug them into the equation. These are the concentrations of the lead ion. This is the concentration of the bromide ion, and I square it. So squared times 8 times 10 to the minus 9. I come up with a Q of 6.48 times 10 to the minus 29. That is my Q value. In order to answer the question, will a precipitate form, I'm going to compare it to my K value. And since Q is much, much less than K, all it has to do is be less than K, Q needs to get bigger. To reach equilibrium. and it will do so by shifting to the right. If Q needs to get smaller, it will shift to the left. If Q needs to get larger, it will shift to the right. And so if that equilibrium reaction shifts to the right, this is the equilibrium reaction. All right. If that equilibrium reaction shifts to the right, no precipitate will form. So I have a Q value, and I have come to the conclusion that no precipitate forms. Piece of cake.